All right, so I'm going to kind of discuss the strategy for trying to match up the situation cards with the graph. The strategy is usually whenever you have a new situation, you just want to draw it and then kind of create a sketch of the graph and then kind of just jot down what are the important details of the graph. And then sometimes Desmos might come up because you could always use Desmos to check your graph to see if it actually does match up. Because some of these will have a little bit of like trickiness to them. But let me go ahead and choose a situation. Let's see this situation right here. Card number. Actually, let's do card number one. Let's look at card number one situation, and we'll try to match this situation with a graph. So the diameter of the wheel is 40 meters. And again, you just want to choose a situation, start matching up the graphs, and then go from there. And then you can match up the equations. So situation number one has a diameter of 40 meters. The Ferris wheel has this diameter, 40 meters. And the height of the axle above the ground is 60. So this is 60 meters. And then there's the part that says number of turns per minute. Now this part we don't yet consider until the very end once you're trying to do trial and error. Like if there's two graphs that look very similar, how you do that, like number of turns, is if a graph it looks more squished in horizontally, like more waves per minute, then you would know to match it with that versus one that has less turns per minute. But for the moment, we don't have to consider this. This is just like at the end when you have like two very similar looking ones, you don't know which to match it with. Okay, so once we have our sketch here, what's good is to kind of create a sketch of the situation itself, how it starts, how it moves. So because the diameter is 40, that means half of the diameter is 20. So if this is 20 and this length is 60, that means that this remaining length must be 60 minus 20, so that's 40 meters. That means when t equals 0, you start off at 40. Let's just say this is 40 meters. So this is our starting point. When you're here, you're at a height of 40. Then you move up. Let's go to the next part. When you're up here, though, you're going to be at a height of the axle, which is 60. So after like 1/4 of a turn, you're going to be at 60. So if this is 40, we'll just make that 60. It's like counting up by, actually, no, if this is 40, that's, well, it's kind of not to scale, but it's okay. I kind of just, because this is up by 20, and 60 could be down here a bit, but that's fine. It's not going to be perfectly to scale. And then once you hit up here, you're going to be at a height of 40 plus 40. So that's going to be 80. So let's say 80 is up here as our maximum height. Once you're halfway there, then you start going back down. Over here, you were originally at a height of 60. So we're going to be back down to 60. And then you go all the way back down and you're back down to 40 once you make it one round in. So this is kind of like a sketch of what the graph should look like. The only thing is these numbers right here, I divided it by 4. It might not match up completely with what you see because it looks like in our situations, like for example here, this looks like it's in seconds because in no way is it going to take, unless it's a very slow Ferris wheel, 20 minutes to do one cycle or something like that. So this time could be seconds, it could be anything, but what this is just a sketch, like a quarter of either, it could be a minute or a quarter of an hour, whatever it is. The time here is just like a little sketch of the time. Like I said, just be aware that this could be seconds in this graph and it could be minutes on the sketch that I have right here. Just because it made it easier to do it in minutes for me. And then it could be coincidentally in seconds on the other one. So now the next thing is you want to just jot down features. So one important feature is that it starts at 40 meters. Another important feature is the midline. So this is the midline of my cosine function. It's at 60. And then another thing is the maximum is at 80 meters. So those are just important key things that I'm going to look for when I start to match these graphs. And some of these graphs look very similar to it. Like, for example, if the number of rotations is the only different one or something like that. So let's see. So remember, we're looking at trying to match situation number 1. And let me just pull up that card again. Situation number 1. And then remember the picture that we just drew. So we had a midline at 40, at 60. It started at 40, and then its maximum was at 80. So here I see that it starts at 40, midline is at 60, and the maximum does appear to be 80. And it looks like that it does one round and about one round of a cycle, and this could be about, we could say 25 seconds. So that could be a possible match for number 1, right? This looks like it's a good one. This one, no, starts at 80. Nope. We have to find which starts at 40 to start sorting out which it could be. Nope. Which other graphs start at 40? I don't see any others. This one starts at 10. This one starts at 40, 80, 60. Yeah, I mean, it looks like these two, situation 1 has to be card C. The one that we just did has to be card C. So we have this graph matches up to this situation, and then the last thing you